Okay, let's do this. Let me tell people that I'm doing advent of code, doing hashtag advent of code 22, day 15. Let's not try to be funny and just get these messages out so that we can tell people that we are doing this. Let's also just go to my Telegram and to Andrew's Telegram. That should be fine. And tell a few people on Discord. There, and let's also tell the C# Discord and the CryptoMonkey Discord that also has a nice advent of code room, and I can drop it for my friends in Snootyland and the Jonas Sarola game server. Why not? Because they love coding as well. Okay, so that should be good. Advent of code, day 15. Oh yeah, let me pop up the chat so that I can see if you guys write something. Boom, and I still need to switch. Like I said before, I have like a premium on a different level. So now I need to reload this so that I can actually pin and share links. So yeah, now that that's out of the way, let's take the challenge for today, pin it in the chat so that people can follow along if they're not familiar with it. And let's start to read day 15. Take a sip of my cappuccino as always. Let's go. Beacon exclusion zone. You feel the ground rumble again as a distress signal leads you to a large network of subterranean tunnels. You don't have time to search them all, but you don't need to. Your pack contains a set of deployable sensors that you imagine were originally built to locate lost elves. The sensors aren't very powerful, but that's okay. Your handheld device indicates that you're close enough to the source of the distress signal to use them. You pull the emergency sensor system out of your pack, hit the big button on top, and the sensor zooms off down the tunnel. Once a sensor finds a spot it thinks will give a good rating, it attaches itself to a hard surface and begins monitoring for the nearest signal source beacon. Okay, this gives me flashbacks to something we did last year. And that was something that I had issues with, because you'd have to, at a certain point, it would send off a sonar and then it would return points, and then you'd have to navigate, but you also had to rotate. And I got lost in that math a bit, so let's see if this one, if I can figure this one out. Sensors and beacons always exist at integer coordinates. Each sensor knows its position and can determine the position of a beacon precisely. However, sensors can only lock onto one beacon closest to the sensor, as measured by the Manhattan distance. Okay, so Manhattan distance is just, you count up the difference in the y-axis. So if you go up to one to the right, that's 3. If you go upright, that's 4, etc. So it's just the difference in x, y combined. So the absolute values of the differences of both, that's the Manhattan distance. There is never a tie where two beacons are the same distance to a sensor. It doesn't take long for the sensors to report back their positions and closest beacons, your puzzle input. For example, bum 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 bum. Okay. So yeah, now you can see that there are a bunch that report the same beacon. So that would give you like a radius around it. Yeah, this will be an interesting one. And so here we have another group of 3 that all see the same beacon. So consider the sensor at 218, the first one. The closest beacon to it is at -2,15 for the sensor at 9,16. The closest beacon to itself is at that. Drawing the sensors as S and beacons as B, the above arrangement of sensors and beacons looks like this. Okay, so you have a beacon here, then a beacon here, then a beacon here, 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 and then here. So you need to follow a line or something. Let me see. This isn't necessarily a comprehensive map of all beacons in the area though, because each sensor only identifies its closest beacon. If a sensor detects a beacon, you know there are no other beacons that close or closer to that sensor. There could still be beacons that just happen to not be the closest beacon to any sensor. Consider the sensor at 8,7. Yeah, okay. The sensor's closest beacon is at 2,10, so you know there are no beacons that are close or closer in any position marked hash. 2,10. Ah, okay, like this. None of the detected None of the detected beacons are so like this. To explain what's happening here, if you look at this one and it sees this beacon only, you can basically draw a line around for all the Manhattan distances of that distance and closer. So that is interesting to generate this pattern based off of the Manhattan distance. So basically you take this length and then you go up, right, down, left, and then traverse diagonally between them and all values. So that is interesting. Because due to the ASCII format, this looks like a diamond shape, a diamond shape, but it's actually like a rotated perfect square. This sensor closest beacon, yes. None of the detected beacons seem to be producing the distress signal, so you need to work out where the distress beacon is by working out where it isn't. Okay. For now, keep things simple by counting the positions where a beacon cannot possibly be along just a single row. Okay. So suppose you have an arrangement of beacons and sensors in the example above, just in the row where X is Y. You like to count the number of positions the beacon cannot possibly exist. The coverage from all sensors near that row looks like this. In this example, the row where Y is 10, there are 26 positions where a beacon cannot be present. Consult the report from the sensors you just deployed. In the row where Y is, Jesus, how many positions cannot contain a beacon? Okay, so that is interesting. So we already know that we have a giant search space. We already know based off of this that it will probably be giant areas. So you don't want to So you don't want to actually fill out every every value there. So basically what we need to do is, first we need to parse all of this, and then we need to build out these values like this, but just doing this, and then you can basically calculate that probably, because you then just need to have the ones where their shape intersects that Y value. And then it needs to do overlap calculation. Okay, this is interesting. It's a lot harder than I thought it would be already. Okay, let's see if we can do this. It's an interesting issue. So yeah, as you can see here, they are in the millions, and the square sizes are like 50k offset in X, etc. So this will be giant. So even if you do a sparse map out of this, where you just fill in the areas that are marked here, it will be a lot. So we need to be smarter than that. But that's okay, we can do that. For now, I think if we just, hey Smap UK, welcome. For now, I think what we need to do is just first parse all of this out, then record for each X and Y column that it triggers, just record the reference so that we can look up the actual data, something like that. En Luc, goedemorgen. Okay, so let's just get started with this, and we'll start with the test input because that one is way more doable and visualizable. So yeah, let's clone day 1, day 0, and make it day 15. Call this day 15 as well. Set the base value and we override our input. Let's see, I'm stuck on 1 star today so far. I need to rethink. Okay. I've already heard from somebody that said that 1 was easy and that 2 they couldn't be asked and just brute force it. So apparently there is still a naive brute force way that you can solve it. So, but yeah, having a bit of a think is not a problem. Let me see. With the way that this is written, it could actually be parsed with the regex. So let me just do that. First time using a regex, this advent of code, const string xy pattern is okay, and then we have x is, and then we capture x as actually sensor x, and this is d plus. Let's comma y is, and now we do the same for the y of the sensor. Actually, this can be backslash minus question mark because it can be a negative number. And we can just call it xy and execute it twice because it should give 2 matches each line. Smap UK, my brute force is still running, but I think it will take too long. Okay. Okay, so we do static read only regex. Xy regex is new, no, not in, new this, and we do xy pattern regex.compiled. Okay. So we do input 2 lines, select yeah, for each var string, actually it's a line in this. We do match m. M is xy regex of match line. If not m.success, so application exception dot parse xy. I need to new it up. Okay, we also have the actual result is a list int x, int y, and this becomes like this. Sensor int x, int y, beacon. Readings, no, it's actually sensors. Boom. We renew it like that. Let me just put var here so that the line is not that long and it doesn't duplicate it. And I should switch to 2022 and just have all the new stuff. So we do int x, int y, sensor beacon. Sensor is int.parse m.match groups x dot value and this y, and the m is m dot next match. And do the same, and we don't look at it again, and then we do beacon is this. And then we do sensor.add sensor beacon. And this is a new pair. Okay. Sensors. Console right now. Something like this. Looks better. Okay. So now if we make sure that we actually run day 15, remove this one, go back to our code. Okay, so now we have all of that parsed. Yeah, that matches up. Okay. So now we need to int Manhattan distance sensor beacon. Beacon.x minus sensor.x, and this is math.absolute plus math.absolute. Let me scroll into view here. Beacon.y minus sensor.y. And I can just call this A and B and just this, and we do public static, and we move this to the extensions, so now we can use it next time as well. So now we can do reading sensor Manhattan distance reading beacon. So we have so if we run it like this, it tells us the Manhattan distance for each of those as well. So this also gives us the what do you call it? Yeah, just basically the size, because from each sensor, yeah, it will always report the closest, so the cone that it makes out of that should be fine. So basically, if we do something similar to what we did here, and let me put it into the case here, because I don't know if we can use it. Build diamond basically this becomes to the public class exclusion, oh no, DeadZone. Let's call it DeadZone. And basically this is public top right, bottom left. So yeah, just that's public constructor here. And we can do it like this, that it can generate that itself actually. So we will build the DeadZone from sensor beacon. So we have a public int radius get private like this. You should always just make these private because we need to set them. So here we have set. In this case, it's radius is this. So we do top is beacon dot x, and then we do beacon dot y minus radius. Yes. And basically every value except the beacon itself needs to be included in this. So if you look at this shape, oh no, it actually strips out the edge because there could technically be one in that. Okay, so the radius needs to be one less than that actually. So it's the Manhattan distance minus one. That will be the exclusion zone radius. It's a good thing that I caught that here because that would have been a pain. So yeah, top right is beacon dot x plus radius beacon y. Bottom is beacon dot x beacon dot y plus radius, and left is beacon dot x minus radius beacon dot y. Okay, so now what we can do is also do like public enumerable int y axis. So basically this lets us give every y axis, or we can actually just build that. Let's see. List hash, we can make it a hash set int y axis because this is the only one that we care about. So we can do why is this new boom, and then we do for top dot y for int y is top dot y is smaller or equal to bottom dot y increment y, and then we can do y axis dot add y. So basically now we have a helper class that gives us the DeadZone and also keeps track of which y axis it has a value in. And so what we can do now is public hash set int at x int x. It's actually x at y. At this y value. So now we can do result is new like this. No, let's not do that because we just need to have a pair int start x, int and x, like this. Do the like at the x at the y level, there are 26 positions where the beacon cannot be present. What if a sensor would be on it? No, then it would report that instance as well. So even a sensor in this line would be fine, and it counts the other beacon. Let's see. No, in this one there is a beacon. So let's say if we have this is 28 characters. Wait, what? These are 28 characters, and they say in this example in row where y is 10, there are 26 positions where a beacon cannot be present. Why? Because this beacon here am I crazy? Let's see. Okay, yeah, Notepad is crazy. Okay. So that one, and we exclude the actual beacon in there, so it's 26. Okay. So we need to make sure hash set int exclude it. Okay, let's do it like this. Whew. And we should also probably just track the actual beacon and sensor. Let's swap those. So we do sensor is sensor, beacon is beacon. Okay. So now we can do if y-axis contains y, else now I can just do the negative here. If not contains, throw new argument exception. We don't have DeadZone at y. This is y. Okay. So now we can do. We need to have the actual difference. Let's see, because extra int local radius is map.absolute sensor dot y minus y, right? And then we remove this from the actual radius that we have, radius minus this. So because that is the remaining radius that we can still do, right? Let me think. No, that's not correct. Let me think. Let me go back to the example to work this out. Because basically my idea is if this is a sensor and we get here, then my distance to travel on this axis is actually this minus disk length, right? So let's see, this is 1, 2, 3, 4, 5, 6, 7. Oh, there's another sensor here, 8, 9. So the radius here was 9. Am I correct? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So the radius in this example is 9. So if we go down, so it should be 9 in every direction, right? This is also 3, 6, 9. Yes, and this becomes 8, 7, 6, etc. So yeah, if you take the radius and subtract the difference in y, that will give us the amount of things in that axis. Okay. But then we need to account for if the beacon is in that axis. Okay, so actually its int result is no, it's still local radius. That's a good name. So we remove the difference, the absolute difference there. That's the local radius. So our result is actually sensor.x minus local radius, comma sensor.x plus local radius. So this is the range for that line, and then we need to know if there is a start x is this and x is this, and then we need to know if the beacon or the sensor is on that line, that we need to remove it. So if sensor.y is y, let's see if y equals sensor.y. So we have our exclusion here. It's new y. Excluded at sensor.y x. Yes. And we do the same if y is beacon.y. Then we probably don't match, but I don't think this can ever happen. So let me throw new application exception can't. Is that true? Oh, that's not an issue. But it should never be able to actually be in the actual range there. Yeah, I don't think this one can ever be in the actual range, but I'm going to add it and set a breakpoint so that I can check it. Beacon.x, because don't think this can ever fall within start and. So we return start x and x excluded. So basically we could always just make sure that we exclude that one, but that's okay. So let me see. And then we need to have something that can take a list of these values and then build a total range value, right? Let's see. Int y that x current, and this becomes a list of this. Deadlines. So we do int result is 0, and maybe this needs to be longs. Who knows? No, probably not for a single line. That's not possible. Yeah, it is possible, but no. So we need to do hash set int x excluded is new hash set, and then we do deadlines, but select many x excluded like this. So these are all the X values that we need to remove. And then we need to make sure that we can trim all the values in ranges so that we don't count any overlap. So we should probably do var order is deadlines dot order by x dot start x then by x and x. Okay. Then we do for each var line in ordered. So we have our list of ranges now. So we do list list actually. We do for int I is 1. I is smaller than ordered count. Increment I. Let me think. Or I can just do it like this. For line in ordered, let's just do it like this. It's no. Basically, you just need to count int last x actually is -1. So we need to keep track of those int ranges. Non-overlapping is new like this. How long did you guys take coding this? Let me warm my hands in the meanwhile. It's so cold in here. Okay, let's see that x count. So we compare if line dot start x is larger or equal last x. This is fine. No overlap. Okay, no, I actually need to keep track of the previous because part 1 was 30-35 minutes. Okay, yeah, I'm still coding. I need to keep track of the previous because I need to take into account the excluded ones. So we do previous is null. Part 2 20 minutes but still running. Oh, okay. Not sure, 50 minutes or so. Okay. So we can do -1 -1 no. No, that's not good. Let's do it like this. So if previous dot and x, no overlap, else line dot start x is previous dot end x plus 1. No, okay, I could just do non-overlapping add. Luke says, I'm working on a new version of part 2. My V1 brute force is definitely too long, but I have a new idea. Okay. Let's see. Non-overlapping becomes, it's just the same, but I do need to let me just keep the same thing here. I can just do this. And otherwise, I'll add this one. So we do line dot previous dot end x plus 1, and then we do line dot end x. Let's make sure that we update the exclude as well. If it's not, oh wait, damn. If the exclude falls in the previous one, then I need to add it there too. No, we don't actually have to care about that because we have the unique list here. We can do that separately. Okay, so let me move this because this is not needed. I can just do this. So I can do line dot start, line dot end. This is fine. And otherwise we do it like this. Because afterwards we can still take out the overlap there. So this will give us a new set of non-overlapping, and they will all be connected. So now we can do for each var line in non-overlapping. For each var excluded in excluded, if line.start is smaller or equal to x and line.end x is larger or equal than x. This is correct, right? Yes. So we do int line count is line.end x minus line.start x. And we do okay. So we do int sum is oh no. We can do result plus is this. So now we do result plus is line count. Come on. And then we do return result. Okay. Okay, so let's see. For DeadZone. Are you winning at life? Who knows? Is new DeadZone, and this one be reading that sensor, reading that beacon. Also, good morning, Anders. Welcome. Thanks for stopping by. And then we have our target X that we need to read. Oh, let me just do this in part 1 actually. I need to define this here and just make it uppercase and public to the class. So let's put that here. So we initialize that and then we can use it everywhere. So in part 1, we build the DeadZone. And this one actually will be okay. So we do var DeadZones is new this, and we do DeadZones.add DeadZone.x DeadZone x at y, and this is y to count. We count 10 here. Okay, and then we do this one. Int result is that x count that zones. And then we do console.writeLine that zones at y to count, which is the result. Okay, let's see if this works. Nice. We don't have a DeadZone at y. Okay, so I should test actually all my entries first before I just assume. So we do if DeadZone dot y axis that contains y axis that contains y to count, and then we do this. Okay, DeadZone's at 10. It says 12. Is that correct? 26 positions where it cannot be pressed. Okay. Okay, let's debug. I'm very curious to see which ones it marked as DeadZone. So we have 5 here. So this one goes from 4 to 0. Wait, 4, 0. So this one is in reverse. So the first one is reporting wrong, so let me fix that. Here we have the same. So there are a few that are in reverse order. Let me see this at y. So I wonder how this can ever return. Wait, let me first check the DeadZones. No, sorry, I mean, I need to check the raw values here first. Let's see. This DeadZone, it goes from -2. Let's see, the center is from 2 to 18. Let's see what it does here. Radius is 6 minus, let's see. Mine crashed with out of memory. Okay. Let's see, math, 18 minus 10. So that's 8, and it's bigger than the, wait. Okay, so my local radius here is wrong. Let me fix that. Don't solve the code, solve the symptom. Already 64 gigabyte, time to get more memory. I have 128 here. But yeah, let me see. Because it wants to know at y10. The sensor is at 2,18 and the radius is 6. Oh yeah, so it's actually easy. If this radius is larger than 0, then it's good. Because it doesn't have to be at that location. Let's see, 218. It reports at 10. So does it actually have a value there? Let's see. Y9, Y15. Oh, I have the beacon here. This is wrong. This should be the sensor. My bad. Everything should be based off of the sensor, not the beacon. Let's see. Yeah, this makes more sense. Okay. So now we have 4 dead zones, and we have actually correct ranges, and the value is 20. Is that what we expected here? 26 positions where the beacon cannot be present. Okay, so that is not good. Let me debug what it does here, because this is the part that we want to see. So if we just move it to the side here, and let's see what it thinks the dead zones are. So it says here, it goes from -1, so that is off by 1 already. See, because this is 0, so it should be -2. Where is my code? So this one should go from -2, but this one. Let's see, and the outmost range should be 0, 10, 20, 25. So 24 should be the last range, and this one is 23. So I'm off by 1 on the sizes there, so I subtract. Should probably be, this one needs to be +1. So this local radius needs to be this +1. I think, let me check. $24, still not correct. Let me see the dead zones. What are actually the excluded ones? Let me see. No. So there's actually overlap in this one here, so that is interesting. Why didn't that? Ah, I'm an idiot. Let's see. Okay, let's see. Because I need to update the previous here. Previous is line. Now let me make sure that this isn't executed too many times. Okay, so in this case, start x is 0. What is x is 2, and end x is 2. Okay, so line count in this case. Wait, end x minus start x. But this is actually, this one needs to be +1. Because it includes both the starts and the end. Okay, so let's do this again. So yeah, this line count is 3 because it goes from 0 to 2. inclusive, then it needs to become 2 because it needs to remove one of them. Let's see, start x is 2. Okay, so this one was 13 and it becomes 12, so that's also correct. I think this one is correct now, let me check. DeadZone's 25, Jesus, so close. Let me line start x, line of end x. Let's do -1 for x x. Okay, so let's see. We have this range. Oh, but it's, why didn't it start at the -1? It's weird that it started with the 0,2 and not the where is the -1 that should be here? Because we're missing the one that starts at -2, right? Let's see, it excludes 2 from that range as well, and then those are correct, and then that. So what we're missing here is actually the -1 and -2 values there. Why didn't it do that? Let me see. So is this one off by 1 as well then? Okay, let me just debug further. I should probably just draw them out, but let's see. Nick, we need to get a nice hit so we can get a Zen for Epic workstation, so we can throw 12 slots of DDR4. Yeah. Yeah. Ah, that's not good. My coffee is getting cold. Let's see. DeadZones. Which one is this? This is this sensor, right? No, this one is a... Oh yeah, this is this beacon, no? Let's see, it says there's a beacon at -2,15. Oh yeah, okay, that is this one. Okay. And the sensor is at 218, that is this one. So this one doesn't come into play here. Okay, that's fine. It doesn't contain the y-axis. Okay. 1016. Okay. So that's this one. But that has a beacon next to it, so that also does nothing, right? Yeah, let me just see what this one does. And I don't need to execute this because this needs to be DeadZone.y and no .sensor.y. Okay. Index start x. So this is wrong. Let me think. I think this one is still correct, but let me think. Local radius is sensor x minus that. Yeah. Okay, let me just continue till I find the sensor at 10. That's the interesting one. This one at x10. No. It's a sensor at 7. Did we already get that one? Let me see. If DeadZone.sensor.y is 7, and actually I could just do is 7 comma no, it's minus 2,7, right? Minus 2, 7. So right line. Okay, let me run this again and I inspect that case just to make sure that it's correct. Where's that sensor? Oh, it's never mind. It's 8,7. It's this one. I keep reading just the lower numbers and I get thrown off. My bad. 8,7. Okay, let's try this again. Okay. So DeadZone. When we go the left here. Let's see, so mine is off there by 1 as well. Because the sensor is 8,7. So the left should be minus 1. So why isn't that correct there? Okay, let me go back here. Debug this, set next statement, jump into it. Oh. Set next statement. Is this 9 now? Yeah, okay, my bad. Jesus Christ. But the sensor is never part of it, so yeah, okay, radius is 9, okay. Just a simple bit of debugging. DeadZone 25. Okay, almost there. Looks like my V2 is going to be slower as well. Okay. So I just want to make sure that this sensor here is correct. So let's see, left is from -1. Yeah, 7 minus 1. Or is that -2? No, that's -1, right? 0 minus 1. Yes, okay, and then the right becomes 17. That should also be correct. The top is 8 minus 2. Yes, and then the bottom is 816. Okay, so that seems to be correct. Okay. So then this one should be for this one here. Let's see. -2, 1, 0, 1, 2 from 2 to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. From 2 to 14, is that correct? Yes. And excluded, we have index 2 for that detail. Okay, so that should be correct, right? That is the... okay. That count. Okay, so I'm really wondering here. We don't care about this actually. Then why is it returning $14 there? Wait, what? Oh, it does -12 here. So 14 minus 12 is 26. Woohoo! But why does it do a reverse order here? Let me check that. Oh, because the ordering is wrong now. Am I reading this correctly? Because it takes the previous and then it overlaps. Okay, so I do need to then by x exit. Come on. At x. Was that the issue there? It's so weird. Because this one goes from 14 and then 15. Okay, let me just... so annoying this. First the deadlines. So we have 12, 12, 2, 14, 2, 2, -2 to 2, 16 to 14, 14 to 18. Okay, so this is fine. Except the ordering isn't correct. So if we order it, what do we get? -2 to 2. Then from 2 to 14. 12, 12 is completely swallowed by the previous one, so we can just ignore that one. Yes. Then we go from 14 to 18. And then from 16 to, so this should be adjusted. So what we need to do is, let's see, if line.startx larger, no wait, if line.endx is larger than previous.endx, and otherwise we don't actually need to do this because it adds nothing. Okay, so do else console.writeLine skipping, and let me move this code back here so that we can see it, skipping because it falls within the previous line.startx, line.endx. Okay, so does it make more sense now? 29, that is still not correct. Did it skip it? Because I don't see it skipping here. Let's do this again. Oh, I need to do this as well. Okay, so now we're just off by 1. Jesus. Let's see. We have these here, so that is just 0 and 2. But why does it start at 0 when our range starts at -2? That's the thing that I wonder. Because we start with having a good value there. Smups UK says, I'm off to bed to get some sleep. Good luck. Thank you. Yeah, I think it'll be okay. Okay, I just need to figure out my combination of non-overlapping lines, and yeah. Yeah. So let's run this again, because the deadlines that are fed into me, there is a -2,2 that I don't see. At least it doesn't print out. Let's see. So ordered. Ah, I'm an idiot. I'm a real... God damn it. Sorry. Int.min value. Jesus Christ. I can hit myself in the head when I do stupid stuff like that. Because I initialized the previous with -1, -1, and there are negative ranges here. Okay. Whew. Okay. So now I need to remove this one because it needs to be larger as well. Let's see, and one. Let me just step through this because there's still a bug here. Start X, yeah, this one is good. Okay, now we have the 2,2 line. Oh. It actually needs to be like this. And now it's correct. Okay. Sorry for that, guys. Let me just remove some of these right lines. Okay. Why am I printing this out twice though? Oh, yeah, find all references. That I should do that in this thing here. It feels like I'm printing out all these twice. See, it does it once and then it does it again. Okay. Oh, that's the ordered one, I think, right? Oh no, I have this one in here. Never mind. Okay, so let's do the real input now and update the Y position. So at Y 2 million, okay. Whew. So let's see if my code actually works. Woohoo! Nice! Oh, that's good. Okay. Your handheld device indicates that the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates with no lower than 0 and no larger than this value. Okay. To isolate the distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying X coordinates by that and then adding its Y coordinates. In the example above, the search space is smaller. Instead, the X and Y coordinates can each be at most 20. With this search area, there is only a single position that could have a beacon. The tuning frequency for this distress beacon is that. Find the only possible position for the distress beacon. What is its tuning frequency? So I don't understand this at all. Let me read it again. X and Y can be at most 20. Okay, so why is that? Oh, because we need to fill out this map and then see what's left. Wait. Do I understand that? I don't think so. You multiply its X coordinate by... Okay, let's see. Your handheld device indicates that the distress signal is coming from a beacon nearby. The distress beacon is not detected by any sensor, but the distress beacon must have X and Y coordinates, each no longer than 0 and no longer than that. Okay. To isolate the distress beacon signal, you need to determine its tuning frequency, which can be found by multiplying its X coordinate by that and then adding its Y coordinate. In the example above, the search space is smaller. Instead, the X and Y coordinates can each be at most 20. Okay. With this reduced search area, there's only a single position that could have a beacon. Okay. I don't understand this, because if we look here, there could be a beacon here. Because this is dead space. So why is there an issue? No longer than 0 and no larger than that. Okay, so there wasn't any below 0. Okay. Sure. Let me think. So let me do a naive approach on this and see what that brings me. So we go back to the test input. do this. Boom, boom, boom. So now we go boom, 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 boom. Int min x, int max x. So but where x dot start start x is lower than lower equal to max x, and x dot end x larger equal min x. So this at least excludes all the ones. By the way, we should just do this somewhere else. But let me see, because there is a should probably add that here. Public bool has x in range at y. Int y. We do it like this. Let's see. Boom, 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 boom. So this then becomes and return start x and end x like this. Now we should also probably do this like a capped version. We keep the original, but we just do if we supply those, we do max. Right. Let's see. This could be very wrong, but because we need to still make sure that this is true. Else we just return bullshit here. Return 0 0, 0, new this 0. Like this. Math.max this, min x. So if it starts before, it starts it later, and here I do math.min max x. So this clamps it basically to our range. Let's see. Basically, we need to make this have a max y of 20. I need to go for a quick pee break. I'll be right back. So. Okay, and I'm back. Had to go for a quick pee break. Sorry for that. So yeah, basically my idea was to just make sure that we check all those ranges. But yeah, this one needs to be between 0 and 20. X and Y no longer than 0 and no larger than 20. So. Okay, so here we do max xy is 20. No, we need to actually loop this. So we do for int y is 0, y is smaller than smaller or equal to max xy actually, y plus plus. So here we can do DeadZone, so clear. Okay. Now the trick here that we also need to actually get the we also need to not ignore beacons and stuff like that. So yeah. Oh wait, did I do that wrong in my earlier code? Yeah, that doesn't matter. I should probably actually build the exclude list based on all of these. Yeah, so this is wrong. I need to actually build the exclude list based on all the other things. To do build exclude list based on all sensors and beacons. So yeah, let's make sure that we do that later. Because basically we count the amount of filled spaces in each line and then see if that adds up with the total amount, and if not, then we found it. We can also do like hash set int x int y beacons is actually readings that select menu x dot beacon. No, it's just select actually this. Not select many. New, open this. Boom. You do the same for sensors. Sensors. Now we do exclude both is beacons concat no, union with, I think, right? Union with modifies the current hash set to current. No, let's just do this, because if I do union with, then it modifies that one. Sensors. Let's just make a new one here. New. Okay. So yeah, this should still work. I should probably make these global as well, since this kind of helps. Beacons. I could just call this sensors beacons. Cool. Oh, then we assign it like this, that, and then this. We declare them up here. Okay. Let's see. So for part 2, we're looping through all the possible y's. We clear what we have calculated. We enumerate them. We don't care about this anymore. We get the DeadZone. Sure. We should probably actually cache this as well, because it makes no sense. Readings, beacon, and then we do DeadZone. Okay. Let's make sure that we do that. Okay. Okay, so now we don't have to do that anymore. Okay, so that saves some work there as well. Oh, I'm so cold. I'm just shivering here. Let's see. I can't wait to knock this out so that I can get warm. So yeah, we've done that. And now we need to add DeadZone count, startx, endx, excluded. Yes. Let's see, deadx count. Oh yeah, we need to actually has x in range at y, and this becomes, oh wait, yes, okay, let me fix the right one. Has x in range y, and this becomes y, and then we do 0, max xy. Y. So if that's the case, 0 max xy. Test. Okay. Dun, 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 dun. So we do if result is smaller than xy, console right line possible at y this result. And now we need to go back actually and figure out which one is the one that's gapped there, but that's not too difficult. So let's see what this does, and we still need to do the exclude zone, by the way. Yeah, see, 20. Why does it do this multiple times? At either y, actually. Yeah, my code was wrong there. Okay, and I also need to do that x count, and this needs to be both sensors and beacons. Int x, y. Oh no, actually we can just do hash at int exclude x. Okay. So this one gets just replaced by the one that we have here. If oh yeah. So we do it like this. We ignore the ones that are passed in here. Select any, select x. Where x dot y is y. Okay. So this one builds a new dynamic list of what to. We can just ignore this. Oh no. Basically the same like that. Let's see if I run this. An error. Name Y doesn't exist in the current context. Oh Jesus, I'm so cold. Oh yeah, Y to count here. It's actually Y to count. First one is 26, and the rest of them, it says it can be everywhere. Jesus. I actually need to include those counts here. So that's a good one. Let's see. Var exclude x is this, and then plus this dot count actually. So we need to make sure that we remove it there from the ranges, or just not just ignore it, and then yeah, I think we need to do it in the end. Ah, cool. DeadZone is possible at y11, so that is cool. So the logic works. Y11. Oh man, Jesus. And then we need. Okay, we multiply x by that and then add y. Okay. So now I need to write something that actually figures out what the empty x is here. Let's see. What did it say? X times that and then add y. Okay. Const int mul x multiply x is this. Okay. So now we need to make sure that we can find the empty gap. So now we do int come on, int find gap. Int min x max x, and then we have a list of these values. Ranges. Okay. Actually, I wonder, we already do that stuff here, like the dead x count. Let me see, I just do last gap. No overlap. If line dot start x minus previous at end x larger 1, last gap is line previous dot end x plus 1. So I can now also return last gap. So we do int count int last gap x. Cool. So I do var count. Count result is this. Late start again for me, and that was a bit awful today. How long did it take you? Count result. Jesus. So result is this. Count. This. count, and then we have x gap at last gap. Result last times multiply x. Come on. Plus y. Okay. To solve about 2 hours. Okay. I'm still on par there, I think. -1. Technically, I'm still not happy as it takes about 30 seconds on part 2. Okay, I think I've got it now. 5611, is that correct? Yes. So now let's run the real input, and I think this should actually run pretty fast, but yeah, let's see. But the search space is huge, it's like 2 million lines, so let's see. And it didn't find a space. That's not good. How is that possible? And it also gives me the wrong result now, I think. Let's see. Oh no, 552547. Is that what I had now? Yeah, I get a different result now, so I've effed up my code. Max X should be 4 million. Okay. So my code is fast enough to actually run it, but it now gives the wrong answer for part 1. So I need to make sure that I fix that. Which is annoying. Cool. Let's see if I copy pasted that correctly. Not the right answer, it's too low. Jesus Christ. Did I copy it wrong? No, I didn't copy it wrong. That is annoying. And also I somehow messed up the code so that A isn't working anymore. So yeah, that's the thing. Let me first copy this and then undo it probably. Let me just dump it into, no, let's remove this. Okay. Let me just take a text file and just save in what I have now, day 15. Oh, my part 1 is also, I needed to switch this back. Okay, let me see. Okay, 552, is that the correct one? Okay, let me see. Yeah, okay, never mind. Okay, we're good. We're good. I can make my lightning fast, just about to do it. Okay. So now I wonder, Why doesn't it like, oh, is that an overflow again? Do I need a long? Let me just quickly check if I'm doing something stupid again, because we multiply, and I'm probably just an idiot for not converting stuff to long. Yep, I'm an idiot. God damn it. Jesus. It's so stupid. Woohoo, the code was correct. I'm just an idiot for not thinking about adding it to, converting it to long before doing it. Okay, now it's time for me to warm up. Okay, so how long does the code actually run? Let me see. 15 seconds. Okay. Nice. And the thing that I wondered is if I just start at the max and then walk back, because usually they don't let you do this here. I did that, yeah. That's what I thought. But it's not lightning fast. It's good. I still search the entire space though. I don't actually break out of it. So let me do that. Break. So yeah, mine runs in 4.7 seconds now. Nice. And I could probably, like, if I don't print out this stuff, you know, I can just do this. Like, if I don't do the print lines, it's probably still a bit faster. Oh, no, it's slower. No, 4.8. So yeah. I'm just glad that I got it working in the end. It's always such a pain to find mistakes there. So yeah, it's actually not bad to just print this out. It looks nice. Let's remove the test inputs here. And I already did that. I should refactor this to just take in a list of x, y, and then the excluded x values. Because it needs to account for a global state there. Yeah, I think this should be fine. I like it. Let's see. I think that doesn't matter. Yeah, let me just refactor this now. Because we can take the global state into account there. Just not do this, because this is all unneeded work actually. So if I do it like this, boom, 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 boom. Like this. Okay. I should just do let me see if I can just do this out of range of min max. Let's see if this still works then. Boom, 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 boom. This becomes irrelevant here as well. line. Deadlines. This one also just doesn't need to have this one. Just a global there. This one doesn't need that. This is also not needed. There's so much unneeded work here with hash sets that I'm doing. So this is good. And then this one just needs to strip this away. I think that's it, right? Yeah, so I removed 20% overhead, but just removing all the unneeded stuff that I added in there. So now both parts run in about 4 seconds. I'm happy with that. It can probably still be faster, but yeah. I'm not mad at it. And I like that my initial idea worked right away. Let's see. Still not that many people have solved it at this time. Only 6k-ish. Oh, okay. That is pretty cool. Yeah. Let me see if people submitted code to my Discord. Nope. Okay. So what I usually do now is stop the video, make chapters, and post to Reddit so that I can link the video in there as well. But I can probably do that already. So yeah, if you want to see me do that, I'll just do it now and then do the captions later. So let's go back to Advent of Code, day 14. I just like to share my code here. So do markdown mode, hashtag C#. Today was fun. Took nearly two hours to code it all, but nice to see it run to completion fair fast 4 seconds for both parts. Then I usually do code, pipe, video, and this one becomes like this. And then we take the actual let's take the current video link. Dun, 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 dun. So yeah, if anybody wants to share their code, feel free to drop it in my Discord. And let me just grab this code and dump it into a paste here. No, I don't want to throw it away. Let's see, like this. Copy. Code. Okay. And then I just need to copy this link and drop it in a few places, like in the video description. So do the strip off the tracking. So yeah. Let me put this in the video as well. Like this. My code. Boom. So yeah. Let me see. Did anybody want to share the code in the Discord? I guess not. Then I'll end the stream here, and I want to thank you all for watching. Oh, actually, we can take a look at the leaderboard. I forgot that. I have a private leaderboard that I share. That's also in the video description. And it seems like out of the 2 people that joined, only I'm the only one to have solved this day. So let me just put it here in the description as well. So if you want to join just our private little leaderboard, leaderboard invite code. And as you know, I start this like 8 hours or 9 hours after the code unlocks for me. So the chances of me getting high on the leaderboard aren't that big. So feel free to share it here so that we can view your progress as well. So yeah, I'll end it here. I want to thank everybody for keeping me company, and hopefully see you guys tomorrow. Bye bye.